Unsaturated hydrocarbon, alkene and alkyne. Unsaturated hydrocarbon has at least one double bond or triple bond between carbon atoms. Valency of carbon atom not satisfied with hydrogen atom undergoes addition reaction. In the given diagram, CH3, valency of each of the two carbon atoms are satisfied with hydrogen atom. In the next diagram, CH2, valency of carbon not satisfied with hydrogen atom. In the diagram, CH2 double bond CH2, valency of the carbon atom are satisfied by forming a double bond between two carbon atoms. In the diagram, Hc double bond CH, valency of both the carbon atoms are not satisfied by hydrogen atoms. In the next diagram, Hc triple bond CH, valency of both the carbon atoms are satisfied by forming a triple bond between them. Unsaturated hydrocarbon, alkene, general formula CnH2n, double bond between carbon atoms. Alkyne, general formula CnH2n-2, triple bond between carbon atoms. Alkene, CnH2n, ethene, CH2 double bond CH2, valency of carbon atoms are satisfied by hydrogen atoms. Propene, CH3, CH double bond CH2, valency of carbon atom satisfied by hydrogen atoms. Butene, C4H8, but1ene or 1-butene. In the given diagram, CH3 double bond CH, single bond CH2, single bond CH3, we observe that the position of double bond is on the first carbon atom, hence the naming is but1ene. In the next diagram, we observe CH3 single bond CH, double bond CH, single bond CH3. Position of the double bond is on the second carbon atom, hence the naming is but2ene or 2-butene. Propene, CH2 double bond CH, single bond CH3. Alkyne, CnH2n-2. Ethine. In the diagram, we observe the chain is of two carbon atoms with triple bond between both the carbon atoms as Hc triple bond CH. Here the valency of carbon atom has been satisfied with triple bond. Propyne, we observe that the chain is of three carbon atoms as Hc triple bond C, single bond CH3. Here, the valency of the carbon atoms are satisfied, forming a triple bond between them. 1-butyne, but1ine, Hc triple bond C, single bond CH2, single bond CH3. We observe the position of triple bond is on the first carbon atom, hence the naming is 1-butyne. 2-butyne, but2ine is represented as CH3, C triple bond C, CH3. Here the position of the triple bond is on the second carbon atom, hence the naming 2-butyne, but2ine. Homologous series, a group of compound having same general formula, structural pattern, chemical behavior, method of preparation. Homologues. Each member of homologous series is known as homologue. Each member differs from its adjacent member by a CH2 group. In the diagram, the homologues of ethane are CH3CH3. The first homologue is represented as CH3CH2CH3 with a CH2 group in between both CH3 groups. The second homologue of ethane is represented as CH3CH2CH2CH3 with a CH2 group in between CH3CH2 and CH3 group. Homologues of ethanol are CH3C double bond O single bond H. Its first homologue is represented as CH3CH2C double bond O single bond H with a CH2 group in between CH3C double bond O single bond H group. The second homologue of ethanol is represented as CH3, CH2, CH2, C double bond O single bond H with a CH2 group in between CH3, CH2, C double bond O single bond H group. The third homologue of ethanol is represented as CH3, CH2, 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 C double bond O single bond H with a CH2 group occurring between CH3, CH2, CH2 and C double bond OH group. The next and the last homologue of ethanol is represented as CH3, CH2, 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 C double bond O single bond H with a CH2 group occurring in between CH3, CH2, CH2, CH2 and C double bond O single bond H group. Organic chemistry, nomenclature of branched and substituted hydrocarbon. Steps to name branched hydrocarbon. Identify the parent hydrocarbon and name the hydrocarbon. The longest chain of the carbon atom is the chain of the parent hydrocarbon. Number the carbon atoms in the longest chain from the end that gives the lowest number to the carbon atom carrying the substituent. The number that indicates the position of the substituent along with the name of the substituent is prefixed to the name of the parent alkane. Prefixes such as di, tri are added to the substituents that are present twice, thrice respectively in the parent chain. Butane, CH3, CH2, CH2, CH3. Another form to represent butane is as following, in which we observe that the carbon atom on the very right hand side has been branched and it contains two hydrogen group and one CH3 group attached to it. Longest chain rule. Identify the parent hydrocarbon and name the hydrocarbon. The longest chain of carbon atom is the chain of parent hydrocarbon. Here in the diagram, the longest chain is of 3 carbon chain. In the diagram, the longest chain starts from top to bottom and moves to the left hand side and forms a chain of 4 carbon chain. Thus, the longest chain is of 4 carbon. Number the carbon atoms in the longest chain from the end that gives the lowest number to the carbon atom carrying the substituent. Substituted carbon in the given diagram is number 2 carbon. Here, in the given diagram, the naming starts from the carbon on the left hand side and proceeds upward, which gives second position to the branched CH3 group. Hence, substituted carbon is number 2 carbon. In the given diagram, the naming starts from the carbon on the right hand side and proceeds upward. The carbon on the very right hand side has been named as C1. The carbon adjacent to the carbon number 1 has been named C2, which contains one hydrogen and one CH3 group and one branched group attached to it. Hence, the substituted carbon is number 2 carbon. In the figure shown, if the carbon atom is named as following, we observe that branching occurs on carbon number 3, that is, the substituted carbon is number 3 carbon, which makes our nomenclature as false because the substituted hydrocarbon should attain the least numbering. The number that indicates the position of the substituent along with the name of the substituent is prefixed to the name of the parent alkane. In the diagram shown in the figure, the carbon atom has been named in such a way that the substituted carbon, that is, the C2 carbon, attains a numbering as C2, which makes our nomenclature the correct one because the substituted carbon atom should get the least numbering. In the next diagram, we observe that the longest chain is of 4 carbon atom chain, which has been numbered from right preceding upward and has been named as shown. Now, the carbon number 2 contains a CH3 group attached to it, which makes our nomenclature as a true one because the substituted group should get the least numbering. Hence, the compound has been named as 2-methyl butane. The reason being the longest chain comprises of 4 carbon atom, due to which the term butane has been used, and at the second position of the carbon atom, methyl has been attached, due to which the nomenclature becomes in total as 2-methyl-butane. 2-methyl-butane. 2 indicates the substituent attached to the second carbon, methyl is the substituent, butane indicates the longest chain is of 4 carbon. Similar observations are observed in the next diagram. In the diagram shown on the left hand side, the longest carbon chain is of 6 carbon chain and has been numbered as C1 to C6 respectively, with the branching occurs at C2 carbon atom, which has 1 hydrogen and 1 CH3 group attached to it, which makes our nomenclature a right one because the branched carbon atom has received the least numbering, that is C2, on numbering it from left to right. In the next diagram on the right hand side, the nomenclature has been done in the following ways: from left to right, proceeding upwards. The longest chain is of 6 carbon atom, and we observe that the substituted carbon atom has been numbered as C5, which makes our observation and nomenclature as a false one because the substituted carbon atom should always attain the least numbering. 2-methylhexane has been numbered in the following ways, starting from top to bottom, proceeding leftwards, and the carbon atom attached to the substituted CH3 group has received the least numbering, that is C2, which makes the nomenclature as 2-methylhexane because methyl group has been attached to the second position. 2,2-dimethylpropane. Prefixes such as di, tri are added to the substituents that are present twice, thrice respectively in the parent chain along with the number of carbon atoms to which they are attached. Summary: the name of the compound is written with the substituents in alphabetical order followed by parent name derived from the number of carbons in the parent chain. Commas are used between numbers, dashes are used between letters and numbers. There are no spaces in the name. In the diagram shown, it is a wrong way of numbering because the substituted carbon should get the least number. Isomers of butane, chain of isomers, butane, 2-methylpropane. The isomers of butane are shown as follows. Isomers of pentane. Pentane, here the longest carbon is a carbon chain of 5 compounds with hydrogen groups attached to it. Another isomer of pentane is 2-methylbutane with the longest chain of 4 carbon containing chain, and branching occurs at carbon number 2 starting from the left hand side, which contains CH3 group attached to it. The last isomer of pentane is 2,2-dimethylpropane, which has been shown as follows. Substituted hydrocarbon, chloroethane, CH3, CH2, Cl, 1,1-dichloroethane. The nomenclature starts from right to left. The rightmost carbon has been named as C1 with 1 hydrogen and 2 chlorine group attached to it. The second carbon contains 3 hydrogen attached to it, and hence it has been named as 1,1-dichloroethane. 1,2-dichloroethane, the naming starts from left carbon atom. The leftmost carbon atom has been named as C1 and the adjacent carbon has been named as C2. C1 contains 1 chlorine, 2 hydrogen attached to it. C2 contains 2 hydrogen and 1 chlorine attached to it. Hence the compound has been named as 1,2-dichloroethane. More than one substitution in ethane, carbon atoms should be numbered. Substituted propane, carbon atoms should be numbered for even one substitution, unlike ethane. 2-chloropropane contains CH3, CClH with a Cl group attached on the secondmost carbon atom and CH3. 1-chloropropane contains CH2Cl on carbon number 1. Carbon number 2 contains 2 hydrogen atoms. Carbon number 3 contains 3 hydrogen atoms. 1,3-dichloropropane, CH2Cl, CH2, CH2, Cl. On moving from left hand side towards the right hand side, we observe that C1 contains 1 Cl group, 2 H group attached to it. C2 contains 2 H group attached to it. and C3 contains 2H and 1 Cl group attached to it, hence the nomenclature comes out as 1,3-dichloropropane. In 1,2-dichloropropane, we observe that Cl group is attached to C1 and C2 carbon atoms respectively. 1,1-dichloropropane, we observe the chain is of 3 carbon containing compound, hence it has been named as propane with the chloro group, that is Cl, attached on the first carbon atom, that is the carbon atom on the right hand side, which makes our nomenclature as 1,1-dichloropropane. Organic chemistry. Aldehyde. Aldehyde group CHO, C double bond O, single bond H. First member methanol, H, C double bond O, single bond H. Second member ethanol, CH3, C double bond O, single bond H. Third member butanol, CH3, CH2, C double bond O, single bond H. Fourth member butanol, CH3, CH2, CH2, C double bond O, single bond H. Nomenclature of aldehyde: change the E ending of the parent alkane with suffix al. Propanol, CH3, CH2, C double bond O, single bond H. Methanol, H, C double bond O, single bond H. Ethanol, CH3, C double bond O, single bond H. Butanol, CH3, CH2, CH2, C double bond O, single bond H. Carboxylic group COOH. Nomenclature of acid: carboxylic acid. Change the E ending of the parent alkane with suffix al. H, C double bond O, single bond OH. Methanoic acid, CH3, C double bond O, single bond OH. Ethanoic acid, CH3, CH2, C double bond O, single bond OH. Propanoic acid, CH3, CH2, CH2, C double bond O, single bond OH. Butanoic acid. Organic chemistry. Alcohol, ROH, R, any alkyl group, CH3OH, C2H5OH, C3H7OH, C4H9OH. The basic rules of naming alcohol: the longest continuous chain of carbon atoms containing the OH group is taken as the parent compound. Here, the parent compound is 4 carbon atom chain. The chain is numbered from the end nearest the OH group to propanol. The number that indicates the position of the OH group is prefixed to the name of the parent alkane. The E ending the parent alkane is replaced by the suffix ol, 1-butanol. CH3OH, methanol. Different ways of representing ethanol are CH3, CH2OH with OH group attached on the right carbon atom. CH2OH, CH3 with OH group attached on the topmost side of the leftmost carbon atom. CH2OH, CH3 with the OH group attached on the bottom side of the leftmost carbon atom. CH2OH, CH3 with OH group attached on the leftmost carbon atom. Propane 1-ol, C3H7OH. Propane 2-ol, CH3, CHOH, CH3 with OH group attached on the second carbon atom, hence the naming propane 2-ol. Butane 1-ol, CH3, CH2, CH2, CH2OH with OH group attached on the right carbon atom, that is C1. Butane 2-ol, CH3, CH2, CHOH, CH3 with OH group attached on the secondmost carbon atom, hence the naming butane 2-ol. 1-butanol and 2-butanol are position isomers. Another way of representing butane 2-ol is CH3, CHOH, CH2, CH3 with the OH group attached on the secondmost carbon atom from the left hand side. Organic chemistry, nature of carbon atoms. Introduction. Organic chemistry is known as carbon chemistry. All organic compounds are compounds of carbon and hydrogen. Other elements may also be present, but essentially carbon and hydrogen. Unique nature of carbon, tetravalency, catenation, formation of single, double and triple bond, straight chain, branch chain and cyclic compounds. Unique nature of carbon atom, tetravalency, catenation property, numerous compound. Tetravalency. Carbon atoms has total 6 electrons which are distributed in the shell as inner shell contains 2 electron and outer shell contains 4 electron. 4 hydrogen atoms shares its electron with carbon, resulting in the formation of methane, that is CH4. 4 hydrogen atoms can be attached to one carbon atom. Carbon atom can form bond with another carbon atom also. The 3D diagram explains the formation of CH4 molecule. The diagram on the left hand side represents one carbon atom which is attached to 4 hydrogen atoms, in which 2 hydrogen atoms lie in the plane of the paper and 2 hydrogen electrons are projecting outward from the plane of the paper. In the diagram on the right hand side, carbon atom is linked to 4 hydrogen atoms, in which 2 hydrogen atoms are in the plane of the paper and 2 hydrogen atoms are projecting outward from the plane of the paper. In the next diagram, we have 2 carbon atoms. The carbon atoms on the left hand side is attached to 3 hydrogen atoms, in which 2 hydrogen atoms are projecting into the plane of the paper and 1 hydrogen atom is projecting outward from the plane of the paper. In the carbon atom adjacent to first carbon, we have 3 hydrogen atoms, in which 2 hydrogen atoms are projecting into the plane of the paper and 1 hydrogen atom is projecting outward from the plane of the paper. In the next diagram, we have 2 carbon atoms. The carbon atom on the left side of the diagram has 3 hydrogen atoms, in which 2 hydrogen atoms are projecting into the plane of the paper and 1 hydrogen atom is projecting outward from the plane of the paper. In the carbon atom adjacent to the first carbon atom, it has 3 hydrogen atoms, 2 hydrogen atom projecting into the plane of the paper and 1 hydrogen atom projecting outward from the plane of paper. In the carbon atom located on the very right side of the picture, we have carbon atom linked to 3 hydrogen atoms, in which 2 hydrogen atoms are in the plane of the paper and 2 hydrogen atoms are projecting outward from the plane of paper. In the next diagram, we have 3 carbon atoms which are linked to hydrogen atoms. Now, the carbon atom on the left hand side located on the topmost part is linked to 4 hydrogen atoms, in which 2 hydrogen atoms are projecting into the plane of the paper and 1 hydrogen atom is projecting outward from the plane of the paper. Carbon atom adjacent to the topmost carbon atom has 2 hydrogen atoms, in which 1 hydrogen atom is projecting outward from the plane of the paper and other hydrogen atom is projecting into the plane of the paper. Carbon atom adjacent to this carbon atom has 3 hydrogen atoms, in which 2 are projecting into the plane of the paper and 1 is projecting outside from the plane of the paper. In the next diagram, we have 4 carbon atoms. The carbon atom on the left hand side has 3 hydrogen atoms, in which 2 hydrogen atom is projecting into the plane of the paper and 1 hydrogen atom is projecting outside from the plane of the paper, which is linked to the second carbon atom having 2 hydrogen atoms projecting outward from the plane of the paper. The carbon atom adjacent to this carbon atom has 2 hydrogen atom, one projecting into the plane of the paper and one projecting outside from the plane of the paper. And the last carbon atom located on the right hand side has 3 hydrogen atoms, in which 1 hydrogen atom is in the plane of the paper, 1 hydrogen atom is outside from the plane of the paper and 1 hydrogen atom is projecting inside the plane of the paper. Tetravalency. Tetravalency allows to form multiple bonds by combining with different carbon atom. Carbon atom can bind together to form rings, sheets, tubes or spheres of almost any size. Catenation, the property of atoms of element to link with one another forming chains of identical atoms. Carbon exhibits catenation to maximum extent because of strong carbon-carbon bond and tetravalency. Due to this property of catenation, carbon atom can form various types of straight chain, branch chain, and ring structure, thus giving rise to large variety of compounds. Branched hydrocarbon, due to the unique property of catenation, carbon can be linked with other carbon atoms forming branches. Catenation is the property of an element to form bond within itself. Property of self-linking is catenation. Carbon can form single, double or triple bond. No other element can do this. The given diagram explains the structure of 2-pentane and 2-butane, in which butane is linked to the carbon atom with triple bond. Organic chemistry, structure and isomerism. Structure of simplest hydrocarbon, methane, CH4. All organic compounds are covalent compounds formed by sharing of electrons. The essential elements of organic compounds are carbon and hydrogen. The simplest compound is methane, CH4. Methane, saturated hydrocarbon. Saturated hydrocarbon has only single covalent bond. Valency of the carbon atom is satisfied with hydrogen atom. Each carbon atom has maximum number of hydrogen atom it can have. Each carbon atom is saturated with hydrogen atom. Saturated hydrocarbons are known as alkane. Methane. Methane is the first member of alkane group. Meth stands for one carbon atom. Ane stands for saturated hydrocarbon alkane. All organic compounds with one carbon atom begins with meth. All alkanes end with ane. Alkanes have general formula of CnH2n plus 2. Why polar covalent compound need to be in aqueous state? First member methane CH4, second member ethane C2H6, third member propane C3H8, fourth member butane C4H10, fifth member pentane C5H12. Isomerism, same combination of atoms but atoms are assembled in more than one way. Organic compounds having same molecular formula but different structural formula are isomers. Methane, ethane, propane have no isomers. Isomerism starts with butane. Butane has 2 isomers. Pentane has 3 isomers. Isomers of butane, N-butane and 2-methyl-propane. In N-butane, we have straight chain of 4 carbon atoms in which the valency is satisfied by hydrogen atoms. In 2-methyl-propane, the straight chain of 3 carbon atoms and branching at C2 carbon atoms and the valency satisfied by hydrogen atoms. Isomers of pentane. The 3 isomers of pentane are explained as below. In the first isomer, we have straight chain of 5 carbon atom in which the valency is satisfied by the hydrogen atom. In the second isomer, we have 4 carbon atom and branching at second carbon atom and valency satisfied by hydrogen atoms. In the third isomer, we have straight chain of 3 carbon atoms and 2 branching successively at second carbon atom and valency satisfied by hydrogen atoms. Isomers of pentane. Naming of organic compounds. IUPAC name without any reference to its structure is common name or tribal name. Systematic method of naming organic compound on the basis of their structure is IUPAC nomenclature, recommended by International Union of Pure and Applied Chemistry. Straight chain compound and branch chain compound. The figure on the left hand side represents straight chain compound of butane, which is having 4 carbon atoms in straight chain and valency satisfied by hydrogen atom. The diagram on the right hand side represents branch chain compound which contains 4 carbon atoms in a straight chain and branching at second carbon atom and valency satisfied by hydrogen atoms. Organic chemistry. Alkyl group. Alkyl group contains only carbon and hydrogen derived from alkane by removing one hydrogen atom arranged in a chain. General formula CnH2n plus 1. Alkyl group removes one hydrogen from an alkane, a part of structure, general abbreviation R for radical, an incomplete species or the rest of the molecule name. Replace an ending of alkane with YL ending. CH3 is methyl from methane. CH2CH3 is ethyl from ethane. Methane CH3, a methyl group. CH3 methyl alcohol, that is methanol. CH3OH, alkyl group. Methyl CH3 ethyl. C2H5 propyl. C3H7 butyl. C4H9. Functional group. Substituents responsible for chemical behavior. Halide group Cl chloro. Alcohol group OH all. Aldehyde group CHO. Acid group COOH. R OH alcohol. R C double bond O. CH aldehyde. R C double bond O. OH acid.